wonderful sword you are. Yes, indeed. Sword to look at your cute little LED at the tip there. 90 degrees so the Wiimote can see. Yee! Hi. Hi. I don't talk to my sword often, but James M. Nuclear here for Whalebone IR and Laboratories. We were just getting ready to shoot a video for you all. Today we're going to cover Math Standard number 2 of Algebra 1. As I said, my name is James M. Nuclear, Premier Research Scientist for Whalebone IR and Software, where the future is only 2 days away. Today, as I said, we're going to cover Algebra 1, Standard number 2. Let me tell you what the standard is. Students understand and use such operations as taking the opposite, finding the reciprocal, taking a root, and raising to a fractional power. They understand and use the rules of exponents. Now in this particular video we'll probably stop about right there, because the rules of exponents are a whole ball of wax in and of themselves. So today I'm going to explain how to take an opposite, how to find the reciprocal, spelled reciprocal, in case you have trouble with that. I always did. Reciprocal, and taking a root and raising to a fractional power. We'll get right into it. Taking the opposite, finding the reciprocal, taking a root, and raising to a fractional power. This is part 1 of Algebra 1, standard number 2. Finding the opposite is first. Now, finding the opposite of any number is very simple. To look at it, all you need to do is put a dash in front if there is no dash, and get rid of the dash if there is a dash. I try to keep things as simple as possible. So, for example, 500 would become dash 500, but would be read as negative 500, or the opposite of 500. This can be read negative 500 or the opposite of 500. And therefore, also, negative 500, if we started with that, would become 500. Simple application of the rule. If there's no dash, we add a dash. If there is a dash, we take away the dash. Now remember, let me get this out of our way. The opposite of an opposite is positive. You could even say that the negative of a negative is positive, if you wanted to get real confusing. Let's move along. It is easy, but let's keep a few things in mind. Even though these two different numbers, positive and negative, look very similar to each other, the only difference is the little dash, they mean very different things. 80-degree water would be very comfortable to swim in. But negative 80-degree water would actually be ice. And it would be so cold that your fingers would be severely damaged by frostbite if you even touched it briefly. So the reality that we talk about, when we talk about the difference between a negative and a positive, is very, very different. But the way we symbolize them, the way you look at them, is very similar. Just the little dash is the only difference. We need a dash of difference. Here's another thing to keep in mind. Often in algebra, we're taking the opposite of not just a simple number, but a very complex expression, such as 3x plus 7. When we work with something like this, we have to be a little more careful. We have to distribute. Distribute, distribute, distribute. What do I mean by that, in case you're not familiar? Well, when we take the opposite of a complex expression like 3x plus 7, we need to put parentheses around the entire thing and remind ourselves that we are taking the opposite of the entire thing, not just 3x. A common mistake is to put a dash in front of 3x and think that you're done, but you're not. You want to take the opposite of the quantity, the whole thing, 3x plus 7. And that means you multiply the negative by the 3x and by the positive 7. What we'd end up with is negative 3x minus 7. So keep that in mind, and we'll be good to go. You should not put a negative in front of the 3x and think you're done.
That's all for this video. Please proceed to the next video on reciprocals. And here's your little doggy for all your hard work.